Today's focus will be how a nuclear power plant works. Okay, so the first thing that you need to know is that you're going to have to be able to describe what happens for a nuclear power plant. So understand these steps, repeat, 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 repeat until you have them mastered. Okay, so the first thing is that these are the fuel rods, and the fuel rods undergo nuclear fission. This nuclear fission is where uranium, enriched uranium, splits, and when it splits, it releases tons of energy. Okay, this energy is in the form of heat. This heat then heats up water that surrounds the fuel rods. Okay, but this water, which is I'm coloring as yellow, is under extreme pressure. So it never, even though it gets up to about 600 degrees, a little bit less, but 600 degrees, it will never become steam. And the reason why is because it is kept under a lot of pressure. And in order for it to go into steam, it can't be under that much pressure. But this is highly radioactive water. This radioactive water came in touch with those fuel rods, which means it gained that radiation, but it is kept under pressure, so it is very, very hot water, basically. So this hot water goes through this path that I'm going to show right here, under pressure. It's just radioactive water. This is known as your primary loop. And it just keeps going around and around and around and is extremely hot and extremely radioactive. Okay. What I also want to note is that these guys are known as control rods. They absorb extra neutrons. So what happens under the fission reaction in here, the fission reaction produces neutrons, either 2 to 3 neutrons each time it undergoes one division thing. And those neutrons then hit other uraniums, which then can become unstable and undergo fission. So what the purpose of these control rods do is they absorb neutrons. They absorb these neutrons that are then a product of a fission reaction, which means that they are not allowed, these neutrons are not allowed to go on to do another fission reaction. Okay, so if we want the reaction to slow down, we insert these control rods so that they are deeper into the fuel source, which means that they are absorbing more neutrons. If we want to make the process go faster, we pull the control rods up. Okay, so primary loop again, extremely, as a review, extremely radioactive, extremely hot, okay, kept under pressure. Then we've got a secondary system of water. The secondary system water is right here. Okay, what happens is that it comes into contact with the pipes of the primary system right here. Okay, and what happens is it is not kept under pressure. So instantly, as soon as it touches those extremely hot pipes, it turns into steam. That steam then goes through the steam line, and steam, just like wind, has the ability to turn the turbine. Okay, and the turbine shaft then turns the generator, which can conduct electricity, and then goes back out to the houses, which is what we want to do. Okay, the steam then goes by, okay, the condenser, which is the third loop, or the tertiary water loop. Okay, I'm going to actually make it purple. So here's the tertiary water loop. Okay, this is cold water. It has come from a reservoir, a lake, a river, things like that, okay, where cool water is. The cool water comes from the reservoir. It is cold, and what happens is this third system the pipes of this third system comes into contact with this extremely hot water right here. And when it does that, the hot water actually cools down and becomes liquid water, okay? So I'm going to go through this again at the very end, okay? This cool water, okay, is then from the reservoir in the tertiary or the third system, still cold, but what happens is because it comes into contact with this extremely hot water, it too becomes hot, and sometimes it'll go back into the reservoir, and sometimes it'll go out of these cooling towers in the form of steam. I really need you to understand that this steam is just water. It is pure water. There is no radioactive substance in this one. This is not radioactive at all, because it never came into contact with anything that was radioactive, which is only these fuel rods, and neither is the secondary system. This is not radioactive either. The only radioactive water is in the primary system. So let's go through this one more time, okay? Very basic stuff, or the basics of this. So the first thing is that the fuel rods undergo fission. The fission produces lots of heat. That heat then comes into contact with the primary loop's water. That water is kept under extreme pressure, so it never goes into a gas, but it is extremely hot. Okay, that hot water in the primary system then comes into contact with the water in the secondary system, not by contact directly, but by through contact with these pipes. These pipes are extremely hot. The secondary system of water then turns into steam. The steam turns the turbines turns a shaft in the generator, and then the generator conducts electricity. This steam then comes into contact with the water in the tertiary or the third system, which is cool. Okay, and the water in the secondary system condenses back into liquid water, comes into contact with the water in the primary system, becomes steam, and that whole cycle continues. The water in the tertiary system comes from a reservoir, a lake, or any type of body of water. It is cool water, and it comes into contact with that secondary water system, which cools down that secondary system. It, in essence, becomes hot, so it will either be routed back to the reservoir, making the water a little bit hotter, or it will go out a cooling tower in the form of steam. Remember, the only radioactive area is this area. Okay, why? Because this is the area where it comes into contact with the fission or the enriched uranium. Okay, and then the last part is these control rods. Control rods, what their purpose is they absorb neutrons, so they are neutron absorption, which means that they slow down the process of the nuclear fission. If you insert them deeper, they will absorb more neutrons. If you pull them out, they will absorb less neutrons. All right, hopefully you have a basic understanding of how a nuclear power plant works, and have a great day.